Okay, we're going to look at drawing the derivative. This is the only video that we're going to do today, so increasing and decreasing functions we'll leave to next time. Now, let's start this off. Okay, now normally when you've got a function, you plot the x coordinate against the y coordinate, and we're using f of x notation here to mean y. So you plot the x coordinate against the y coordinate, alright? So the x coordinate is a measure of going along the way, and obviously the y coordinate is a measure of going up and down the way. Now what we're going to do now is we're going to start to plot not x coordinates versus y coordinates, but x coordinates versus the gradient, alright? And remember that the gradient is another word for the derivative, i.e. you're differentiating, okay? Now, best explained with an example. So let's try an example one. We're going to draw the derivative. Okay, so let's say we've got a function that looks like this. Okay, now the function has got a turning point. I'm going to say that the turning point up here is the maximum turning point, and I'm going to say that that turning point is 2, 4, and that this turning point here is 5 minus 2. Okay. And it's f of x versus x. Now what we're going to draw is we're going to draw f dash x versus x. Now take note of this. When drawing the derivative, we inspect the curve before, at, between, and after stationary points. So when we have stationary points here, points of zero gradient, that's your turning points, okay? So when drawing the derivative, we inspect the curve before, at, between, and after stationary points. Okay, now just one side point to make here. Okay, let's say we had a curve like this. Okay, and if I was to say, right, tell me what's happening at the curve there. Okay, and if I said what type of gradient does the curve have there? Well, obviously the gradient, as you can see, it's definitely, well, the curve's going uphill, so it's definitely a positive gradient. And I said, if I was to say then, what about the gradient here? It's definitely going downhill, it's got negative gradient. What about here? It's got zero gradient. Okay, so let me just draw another one here. Okay, now I'm going to make a crucial difference here. That y-axis is not going to be the y-axis, instead it's going to be a gradient axis. Now if I then said, right, what's the gradient here? So this slope's going down the way, so it might make sense then to say that the gradient is negative, right? But the gradient is definitely negative here, and it's negative there on this one. But in this one, the gradient there, even though the curve's went downwards, the gradient is actually positive. Now, what's the reasoning behind that? Well, that's because we're not measuring x coordinates versus y coordinates anymore, we're measuring x coordinates versus the gradient. So you want to think about this now, this line is a number line for gradient. Now think about if that was a capital T there, then that might be a number line for temperature. And we would have below zero here, and you would get to zero, and then that would be above zero, so the temperature would start to get warmer, alright? So where would it have zero temperature? Here. Where would it have negative temperature? Below zero, obviously. And where would it have positive temperature? Up here. Now it's not measuring temperature, but it's not measuring y coordinates either. This time it's measuring f dash x. So what we want to be thinking now is that this line here is a measurement of gradient. And where's zero gradient? Well, it's right on the button here. Where's positive gradient? Up here. And where's negative gradient? Down here. So if I was to say what's the gradient here, well, is above 0 on this axis, so it's positive. What's it here? It's above 0 again. What's it here? It's above 0 again. What if I was to say what's the gradient here, 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 and here? Well, they're all on the x-axis. If you go along to the line, that cuts at 0, the gradient is 0. So if I was to say then, what about the gradient here? It could be tempting to say that the gradient there is positive, because the line's going up, but crucially, if you go across to the line, what that's telling you is that the gradient is below 0, so the gradient there is actually negative. Okay, so that's an aside. So what we're going to do now is we're going to draw the derivative for example 1, so let's have that in front of us. Okay, what was that note again? That note was we inspect before, between, at and after stationary points. Okay, so what we're going to do is create a table of x coordinates and a table of gradient. Now we're going to look before, at, between and after stationary points. Now where does the first stationary point occur? It occurs at 2, 4. So the x coordinate is 2. So the first thing we're going to do is expect what's happening before 2. Then we're going to inspect what's happening at the stationary point, that's at 2. Then we're going to inspect what's happening between stationary points, so that is between 2 and 5. I'm going to write that as 2 is less than or equal to x is less than or equal to 5, that means between 2 and 5. Now I'm going to check what's happening at 5, and then finally I'm going to inspect what's happening after 5, that's greater than 5. And I'm going to inspect the gradient. Okay, so let's look at this curve. Now remember, this is now a curve of y coordinates versus x coordinates. So let's look at the curve before 2. Okay, now here's the curve before 2. Right, now what can you say then? The curve is going up. It's going up. It's got positive gradient. How positive is it? I don't know, but it's definitely going up. So I'm marking positive gradient. Now what can I say here at 2? Well, the curve's going along at 2, so that is 0 gradient. What can I say about the curve between 2 and 5? Well, it's going downwards, sloping downwards, it has got negative gradient. What about the curve at 5? Well, it's going along again, it's got 0 steepness, 0 gradient. And what about the curve after 5? Well, it's going back up, it's climbing back up, and it's got positive gradient. Okay, so that's enough information now to draw the derivative. Okay, so it's the x-axis versus the gradient, the derivative, the differentiated function. So you differentiate f of x to get f dash x. Now this line is now a measurement of gradient. Okay, so up here is positive gradient, down here is negative gradient, and along here is 0 gradient. So this is a number line for gradient. So if I put a capital T up here and said it was temperature, this would be positive temperature, negative temperature, 0 temperature. It's not, it's gradient. Positive gradient, negative gradient, 0 gradient. Now the first thing we're going to do is mark in 0 gradient. So we've got 0 gradient when x equals 2. So let's mark that in. 0 gradient, x equals 2. We've also got 0 gradient at x equals 5. Now what do I know about the gradient before 2? Well, I don't know exactly what it is, but I know it's positive. Now if it's positive, that means before I get to 2, it needs to be up here somewhere, because that records positive gradient. Now where is it exactly? I don't know. Right, so what I'm going to do is just mark that in, just with a scribble there. Right, it's going to be somewhere there. What about between 2 and 5? I know the gradient is negative between 2 and 5, so that would need to be down here somewhere. Where exactly, I don't know, so just mark in roughly as a guide. And then what about after 5? Well, it's positive after 5, so it's going to be up here. Just mark that in my guide. Now the crucial thing here is I must go through 2 and 5, but these bits here I just use as a guide, and they're only a guide. So you want a nice curve to go through it, using them as a guide, and I need to go through 2 and 5, and as a guide for these ones, curve right through it, pretty straightforward, that's it. Okay, example 2. Right. Okay, so get the point -3 there. We've got a point there that is 3. I'm then going to say that that is the point 3, 5. And that's the point 5. That's the point 6 -2. And that is the point 7. Okay. So what do we need to do? We need to inspect what's going on at stationary points, before stationary points, between stationary points, and after stationary points. Okay. So where do the stationary points occur? Here, here, here. That's my key points. Okay. Let's draw a derivative. And before we get to that, I'm going to make a table. Every single time we're going to make a table. Okay. Now, let's have a think about this. Where's my stationary points? My stationary points occur, well, the first one occurs at -3. So I'm first of all going to look at x before -3. I'm then going to look at the stationary point at -3. I'm then going to look between stationary points, between -3 and 3. Now you might then think, well, what will I do with this? Nothing. Nothing changes there. That's not a stationary point, so that's only a distractor. Alright, so the x-coordinate is 0 there, 0, 3. That's just a distractor. That shouldn't distract you though. You're looking between stationary points. So that's just getting in the way, forget about it. So between stationary points is between -3 and 3. I then look, so I've looked before -3, at -3, between -3 and 3, between stationary points. I'm then going to look at 3. And then I'm going to look between stationary points again, between 3 and 6. And then I'm going to look at 6. And then finally I'm going to look after 6. Okay, so the gradient. Okay, so before -3, gradient's going down. You can see it's going down, the gradient's negative. At -3, the gradient is 0. Gradient 0. Between -3 and 3, we can see that the curve is going up. Gradient's positive. At 3, it's going along again. Gradient 0. Between 3 and 6, it's going down. Gradient's negative. At 6, it's 0. It's going along, and after 6, it's going back up, positive. Okay, so let's mark our points of 0 gradient to get going. So I've got 0 gradient at -3. That'll be marked there. Remember, this is a number line for gradient. This is positive, negative, and 0 gradient. I've got 0 gradient at 3, and I've got 0 gradient at 6. Now, what do I know? Before I get to -3, the gradient's negative, so that will need to be down here somewhere. Between -3 and 3 is positive, need to be up here somewhere. Between 3 and 6 it's negative down here somewhere, and then after 6 it's positive, it needs to be up there somewhere. Now I need to go through here, here and here, I need to be precise with that, but this stuff is just a guide, and I want a nice continuous U-shape through it. And that's it. Okay, let's try one more. Example 3. I'm going to draw the derivative again, given this one. Okay. Right, so that's -2. I'm going to call that 2. I'm then going to say that that is 1, 3. That's a point 3. That's 4 minus 2. That's 5. 6, 2, and 7. Okay, where's my stationary points? Okay, is that a stationary point? No. Right. What about that? No. No, it's turning points, is that? Yeah. So my stationary points occur here, here, and here. Everything else is just a distractor. So I'll look at stationary points, before stationary points, between and after. Okay, so Let's set up my table, x coordinates and gradient. Okay, where does my first stationary point occur? My first stationary point occurs at x equals 1. What's this minus 2 got to do with anything? Nothing, it's just a distractor, but don't let it distract you. But distractors will come up with these questions. So the first thing that I do is I look before the first stationary point. The first stationary point occurs at 1, so the first thing that I'm going to do is look at what's happening before 1. Now, as you can see, before 1, the gradient of the curve is going up. So I need to look before 1, then I need to look at 1. Then I need to look between 1 and 3. 3's got nothing to do with it, nothing changes at 3. It's negative and it's still negative. It's between 1 and 4. I need to look between 1 and 4. And then going to look at 4. I'm then going to look, 5's a distractor. It's between stationary points here, so it's between 4 and 6. And then going to look at 6. 7's another one that's a turning point, so I'm going to look between 6 and 7. Then I'm going to look at 7, and finally I'm going to look after 7. Okay, so let's identify the points of zero gradient first of all. Okay, so there's zero gradient at 1. Let's just go through from the start actually. Okay, so before we get to 1, there's 1. Before we get to 1, gradient's positive. At 1, curve's going along, gradient 0. Between 1 and 4, the gradient is negative. At 4, the gradient is 0. Between 4 and 6, the gradient is positive. At 6, the gradient is 0. Between 6 and 7, the gradient is negative. At 7, the gradient is 0. After 7, the gradient is positive. Now notice that I didn't involve these points here because they're only distractors, they are not turning points. A turning point is when the curve turns. Alright? Okay, now I'm ready to draw the derivative. So f dash x versus x. Okay, so let's mark in our points of zero gradient. First, zero gradient at 1 on the x-axis, 0 gradient at 4, 0 gradient at 6, 0 gradient at 7. Okay, well, still no. Okay, before I get to 1, the gradient is positive up here somewhere. Why up here somewhere? Because this is a number line for gradient. Negative gradient, 0 gradient, positive gradient. So before 1, up there somewhere. Between 1 and 4, negative gradient. Between 4 and 6, positive gradient. Between 6 and 7, negative gradient. After 7, positive gradient. And you go through here, here and here, but the red dots are only a guide. Take your time. That's it. Okay, we're going to pick them up in class tomorrow.